Next, we're going to use the quadratic formula to solve some quadratic equations. Here I have 6x squared plus 7x minus 5 is equal to 0. This is a quadratic equation in standard form. If I have ax squared plus bx plus c equal to 0, then the quadratic formula says that x is always negative b plus or minus the square root of b squared minus 4ac all over 2a. And the derivation of this formula is in the book. So if you want to see where this comes from, it comes from completing the square on this equation, and what you get when you do that is this expression right here, which is called the quadratic formula. Now let's substitute in our a, b, and c from this equation into this formula. So we'll get x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So there I've simply substituted in the numbers just as they appear in the equation into the quadratic formula. The rest is all simplifying. Square root of, let's see, 4 times 5 is 20, times 6 is 120, and that'll be positive, plus 49 is 169, all over 12. I continue to simplify. Negative 7 plus or minus 13, all divided by 12. That gives me two solutions. One is negative 7 plus 13 over 12, and the other one is negative 7 minus 13 over 12. So here, negative 7 plus 13 is 6, divided by 12 is 1/2. Here I have negative 7 minus 13, which is negative 20, divided by 12, which will be negative, let's see, 2 goes into there, 10, well, let's see, 20 is divisible by 4, it will go in 5 times, and 4 goes into there 3 times, and this is a negative number. So negative 5/3. So I simply put my equation into standard form, identify a, b, and c, substitute them into the quadratic formula, I get an expression like this. The rest is really just arithmetic down to simplify it. If what's underneath the radical here turns out to be a perfect square, then I've got a couple of numbers I can add and subtract in the numerator, and so I get rational numbers for my solution. Here's another example. X squared over 3 minus x equals negative 1/2. Now I can, if I want, substitute fractions into the quadratic formula, but for me it's easier if I work with whole numbers. So what I'm going to do is multiply both sides of this equation by the least common denominator for all the denominators I see, and then I'll have an equation that's cleared of fractions. So I'll multiply both sides by 6. 6 times x squared over 3 will be 2x squared, minus 6 times x will be 6x, equal negative 1/2 times 6, which is negative 3. Writing this in standard form, I have 2x squared minus 6x plus 3 is equal to 0. At this point, the equation's in standard form. Identify a as 2, b as negative 6, and c as 3, and I substitute those numbers into the quadratic formula. X is equal to negative b, which would be negative 6 or positive 6, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. I continue to simplify. That gives me 6 plus or minus the square root of 4 times 2 is 8, times 3 is 24. I have 36 subtract 24, which is 12, divided by 4. This is 6 plus or minus. I need to put this radical in simplified form. 12 is 4 times 3, so I have 2 square root 3, all divided by 4. This will reduce to lowest terms by factoring a 2 from each term. 2 times 3 plus or minus square root 3, and I'll show the 2 in the denominator by writing 4 as 2 times 2. Divide those out, and here's my solution. 3 plus or minus square root 3 all over 2. So two solutions to this equation, 3 plus square root 3 all over 2 and 3 minus square root 3 all over 2. I found them by applying the quadratic formula to this original equation.